Lagrangian function. It is a function of generalized coordinates, generalized velocities, and time. It can be expressed as L equals to L is a function of qi dot and t, where I starts from 1 up to n. Here qi denotes generalized coordinates, qi dot denotes generalized velocities, and t denotes the time. Lagrangian. So Lagrangian is a difference between kinetic energy and potential energy of a system. System means mechanical system, that is L equals to T minus V, where T is the kinetic energy and V denotes the potential energy. Lagrangian equation of motion. It is a second order differential equation d dt of del L by del Q dot I minus del L by del Qi equals to 0, where I starts from 1 up to n. Let us see what is Hamiltonian function. Hamiltonian function is a function of generalized coordinates, generalized momenta, and time. It can be expressed as H is a function of Qi, Pi, and T, where I starts from 1 up to n. Hamiltonian. It is a sum of kinetic and potential energy of a system, that is H equals to T plus V, where T is the kinetic energy and P is the potential energy. V is the potential energy. Another expression of H is H equals to, it is a product of Qi dot Pi minus L, where I starts from 1 up to n. So it is a very useful to find out the expression of H is Hamiltonian. Hamiltonian equation of motion is the two sets of first order differential equation. One is Pi dot equals minus del H by del Qi. Another is Qi dot del H by del Pi. Relation between Lagrangian and Hamiltonian. Del L by del Qi equals to minus del H by del Qi. At some points, Lagrangian and Hamiltonian both are scalar quantity. 2. The Lagrangian equations of motion are in the form of second order differential equations, but in Hamiltonian formulation, two sets of first order differential equation are used. 3. Hamiltonian dynamics makes use of the generalized momenta P1, P2 up to n, Pn, in place generalized velocities q dot 1, q dot 2 up to q dot n in Lagrangian. 4. Both Lagrangian and Hamiltonian formulation are equivalent, but the Hamiltonian formulation is more fundamental to the foundation of statistical and quantum mechanics.